Hello, so we're back, and this time we have a different kind of repair. I mean, yeah, it's a Huawei, and same issue with, like usually, the charging port with the USB-C charging port. But this job is coming from a local repair shop. So when I got the job, the guy said, "Sorry, I follow your video. I use 380 degrees, and I melt the charging port, which is this. Let's have a look under the microscope." And indeed, this port is melted, yeah? We can clearly see the port is melted. Now, this is kind of like, I feel bad when someone is telling me this because, I mean, not only the temperature is important, but also the airflow. On the other hand, you have different hot air station, and every hot air station have different calibration. So 380 degrees for me it's something else compared with a different hot air station. Now this is not even the biggest problem. The biggest problem on the Huawei, it's actually the pads which are getting broken. Like we can see here. I mean those are still good. We can use this, yeah. This one is gone. This one is ground and it's not that important. And this one is ground, yeah. That's not really important. And the plus tracks are fine. So, we have only one missing pad. I mean, this is quite an easy job. So what do you think? How you will feel if someone will tell you, yeah, I done it like you and didn't work. This job came to the computer shop for working fine on the battery. Please replace USB-C socket. So one more time, they tried to replace the USB. Probably they did it for the first time, and the port got melted. Why 380? Because soldering is doing with 380. What about 300? What about 250? What about 200? With 200, you can't even burn the paper. No way you will melt the plastic. So this guide is for the people that are trying to do this job for the first time. Yeah, we're gonna use 200 degrees. With 200 degrees, you cannot melt anything, no matter what airflow do you have, and no matter how long you will hold the hot air on the motherboard. Now, like I said, this is quite an easy one. We have only one pad which is broken. So I'm gonna clean that pad. No, there is ground, that's fine. No, here. The track, yeah? We're gonna solder like a small wire, or maybe we don't even need a wire. We can make like a bridge here. Yeah. Good. So the first step is to do like a cleanup here. I'm gonna start the solder iron. We are gonna use low melt solder, and that will be fine, yeah. 140 degrees low melt solder is fine, no issues. With 140 degrees solder wire, we can use 200 to solder the charging port. I know that it will be people said, yes, sorry, but that solder is not that solid at 140, but it is, yeah? So you have a lot of solder points here. You have here on the sides, you have a bunch of pins. It will be just fine. More than that, let's say in a case, the customer is abusing the port. If you use like a normal solder wire, definitely the port, it will come out with the tracks. Yeah, we've seen a lot of Huawei with broken pads. But using low melt solder, it is possible the broken pin to came out and the pad actually it's still on the board. So I will kind of recommend using low melt solder. Now, rosin flux, rosin is good. You don't need anything else than rosin. We have rosin, yeah. We do have rosin. Now let me grab some solder paste. Now what I'm gonna use the soldering solder paste. You don't have to use this, yeah? So, okay, if you bought it, you have it, it's fine. This is 140 degrees soldering paste. Not necessary to use exactly the same one. I'm just saying. Solder paste. Good. So we're gonna lower the temperature of the solder. Perfect. Now you have to understand how the solder is working. Just because we are using 140 degrees, that doesn't mean the solder it will melt at 140 degrees, because we are mixing the solder with the original solder. And the result, the alloy which it will result, it will have higher temperature compared with that than 140. Perfect. Yes, looking good. Looking good. Good. Now let's grab a. I have some brand new ports here. So this is a brand new port. We're gonna put the charging port there. So I'm gonna set up the hot air at 200 degrees. 200 degrees. Let's see. And the solder is getting melted. Now, just to make the point, yeah, we didn't use flux. Don't worry about the flux. But check here, 200 degrees. Nothing is getting melted. You can see? We can just stop and go and solder the pins manually. Okay, so I'm gonna stop applying heat. Now we can come with the solder iron and normal solder. Yeah, we can use normal solder on the port. You can see it's no downside of using low melt solder, because now here I'm gonna use like normal solder and solder iron, and that's fine. We need some flux, right? Yeah, a little bit of rosin. Perfect. Perfect. And on the other side, normal solder. When I'm saying normal solder, this is 180 degrees solder wire. Perfect. And now we can go to the pins. You remember what I said regarding the pins? I said we're gonna group the pins. So I'm gonna use some rosin, again rosin. Good. So 3 pins together to ground. Those 3 pins together. Three, okay, it's too much. We have 4 pins together now. We're gonna fix that. 3 pins together. Yeah, we have 3 pins together. Then we have 2 pins together here. Check there, 2 pins together. Then a bunch of pins which has to be soldered. Yeah, that's what I don't like new charging ports. You can see the solder is not really getting properly on the pins. You can see? Yeah. Yeah, that's a copy charging port. Yeah, you're right. That's why I prefer to use the original one. And here we have 3 pins together to ground. Oh, the solder is not getting onto the pins. That's crazy. Yeah. Now you understand why I hate to replace a charging port, a genuine one, which is still good, with a copy charging port. Yeah, that's why. Proper poor quality. Okay, let's try one more time. 3 pins together. Good. 2 pins together. Good. Here we have 2 pins together. Good. Good. Then here we have 1 pin which is solder. Solder. Those are solder. Solder. This we have. We need a wire there. This one is solder, and this one is solder. Yeah, we can use a little bit more solder wire. Yeah. Okay. So this one is with the broken track, right? Yeah. Yeah, we don't need a wire. What do you think about that? Now let's clean it. Let's make it nice. Perfect. How is it looking to you? Good. Let's test it. Let's see. I mean, this was taking longer because the port is a copy port. Now we need a USB-C meter. But the idea and the point I'm trying to make is is no risk. You can't melt the port. Let's say you have only one port, you can't melt it. And we have 19 volts. Moving the port up and down, all solid. On the other way, working fine. Yeah. So that's how you do it. If you are not confident, or when you are using like when you try to solder something with plastic, always use lower melt solder, 180 degrees, or you can use 140 degrees. It's not a big difference, but you can use lower temperature on the hot air machine. This port was soldered with 200 degrees Celsius. Good. Okay, just to finalize the repair, I'm gonna use a little bit of UV gel, just a little bit. Okay, that's too much. Yeah, my syringe is broken. Ah. You see, the things can go wrong. Yeah, let me take out some UV gel. It's too much. Okay, that's enough. That's enough. So now we can use UV light. You remember we have that UV light from Temu, 30 watts. Yeah. Perfect. Nearly done. Yeah, all good. All good. So what do you think? Using lower temperature is more safe, so it's not a risk to melt the port. Let me quickly put the board back. Now, I'm not sure what they are saying 380, because all it said, you know what, use 360 degrees. And the plastic can't get melted, or can get melted if you hold the hot air longer. But it is possible on the past to use like 380 to solder the port back, which is not a problem with 380. 380 is kind of at the limit to melt the plastic, but if you are quick, then everything is fine. On any case, what you see in here, it's a proper repair. Yeah, so you have an option like using low melt solder, or actually not fixing the job, not fixing the laptop. 140 degrees, it's a solid solder. I am doing it with 140 degrees. Usually not. When I have like connectors, like phone screen connectors, like phone connectors, yeah, I'm using 140 degrees. But for the laptop, I'm using 180 degrees, which is 40 degrees higher. 180, perfect. I have no problem, no issues. 140 should be exactly the same. So instead of trying to be someone else, on this case to be Sorin, just doing on your way. Just use like 140 degrees solder, and you are safe. I mean, you can't burn the plastic. You can't do it. I mean, this YouTube channel, and you can see I'm getting focused on getting the job done, no matter how. Some people it will say dodgy. I mean, I'm not sure about that. I'm not really thinking about about the job itself. For me, it's more for me it's more important the warranty. You give warranty, okay? So I'm not thinking like how I'm doing the job, what solder I'm using. No, it's about the warranty. You give warranty, 3 months warranty. The job is coming back on the 3 months warranty. I did a bad job, yeah. I'm learning something from this, yes. So I'm not gonna do the same thing next time. So that's the process of learning and trying to optimize the repair and shorter time, and longer life of the device. And I believe this should apply to everyone. Do you have a way to fix it quick? Do it. If it's coming back, you know it didn't work and you are not doing next time. Like the solution with the hinge. Yeah, hinge, hot glue. You know how many problems we have before? We are using like epoxy, like some plastic, some fiber compound, and we had issue. We had the customer saying, "I want to replace the screen, and I cannot open the assembly," and you fix the hinge, so you have to open the assembly, and that's the reason why we switch to hot glue, because it's easy to be opened, the screen to be replaced, and so on. So whatever repairs you see here actually are learned from the experience, are things which are working. So don't take me as an example. I want to do the job like Sorin. Do it on such a way you are confident and you can finish that repair. Like on this case, the charging port. So they just lost about 2 large pizza with this repair. Okay, everything is back in place. Plug in the battery. Plug in the charger. Wait, we have 2 more screws. From where? Huh? Yeah, one is from here. Check here, it's charging the battery with 2.8 amps, which is fine. And we still have one more screw, and I don't know from where. Anyone knows? No one? No, here is no screw. Well, it is what it is. How do you think I have so many screws on my box? Yeah. Okay, so it's charging 1.6 amps right now. Pressing the power button. And I can see the current is changing. Probably it's coming on. Yeah, Huawei, we have picture. Huh? Yeah, and it's loading the windows. Perfect. And check here the current. We are like 2.4 amps, 2.6, 2.8, 2.9 amps. You can see. So I'm gonna stop now. I will say thank you for being here. Hopefully this video is helpful for you. Remember, even if you don't work with plastic, you like solder like normal components, always you can use lower melting temperature solder. It's just more safe. Can you use like the factory solder? Yes, you can. You can solder the port. Probably you're gonna melt a little bit the port. I mean, you remove this port, you use rosin, then you solder the port, and you come with about 380. Yeah, about 380 up to 400 degrees, and you solder the port. You're gonna melt the port a little bit, but it's fine. The pins, it will get soldered. So you can do it on many ways. Okay, see you on the next one. Bye.